Hi, welcome back. In this video, I want to talk more about the weather routing in LuckGrib, and in particular, this video will be focusing on isochrones and the general solution that LuckGrib uses to solve weather routing. There's quite a lot of discussion on this in the online manual. If you go to the introduction, there's an isochrones section, and it goes through the general idea. So the video will go through some of this material, but for more details, you should look online here. So this example is going to be using a boat leaving Nia Bay and heading over to Hawaii. And I'll be leaving Nia Bay at around this time, and then heading towards Hawaii. The vessel being used is a Transpac 52. So Transpac 52s have excellent performance downwind. In kind of trade wind conditions going downwind, they can achieve 20 knots or more. Upwind, they can go, well, they don't do 20 knots upwind, but they can easily do 8 or 10. And on the beam, you get in between those two. So it prefers to head downwind. The fastest point of sail is downwind for our Transpac. So as the weather for this example initially is going to be kind of upwindish, it's going to be interesting to kind of think about what the route will be. So towards the end of this route, this boat will probably take something like 8, 9, or 10 days. So the forecast will be over here somewhere by the time we're arriving. And clearly, for the performance of this boat, you want to be somewhere down here as you arrive. You want to be in trade wind conditions in the fast wind with wind behind you. And as you back up the forecast, the high is still north of Hawaii. So you're going to want to end up being over here probably. If you're over here, then you'd be heading south towards Hawaii in headwinds, and the boat does better downwind. So you want to be on this side of the high. And as you back up further, that's generally the idea. You want to be on the east side of the high, I would think. The problem for this forecast is that as you leave Nia Bay, at this point, the winds a few days later start to become kind of light and confused over here. So now we'll be somewhere in here, I would think. And the winds we have a very light wind area at this point. And going south, we'd have headwinds. And it's kind of a light, confused area. So we have to navigate through those winds in order to get to the trade winds we prefer over here. So that's kind of interesting to think about. I encourage you to, as you work with the weather router, don't just run the router and have it think for you. It's a good idea to look at the weather yourself and try and make your own estimates of what the router is going to do. The goal of the router isn't to replace your thinking, it's to help you understand what the weather is. And it will generate paths, but there are a lot of approximations in the paths generated, which is true of all weather routers, not just LuckGrib. How the boat performs will be an approximation. The performance of the boat on the ocean will be an approximation, the size of the waves and so on. This state of the crew, is the crew willing to trim the sails diligently the whole passage, or to get lazy a little bit and fall off your optimum performance? There's all kinds of approximations. So it will generate paths, but the primary goal of a system, I think all systems, will be to educate you on what your best navigation options are, and then you make the decisions. But having said that, the paths created by LuckGrib are as good as as good as any system available. So now that we've spent a little bit of time thinking about it, we'll have the system generate a solution. At this point, I'm not going to set a target point to Hawaii. I'll just have the system generate an entire solution. So in something like a second, it was able to generate a solution for how it would travel to any point in this weather file. So now you can place the cursor anywhere here, and you can see what the system, how it would get there. So we can see a few things. That there's isochrones being generated I'll just make the display a little simpler by having it not show the group file. So you can see this white advancing line, which is an isochrone. That represents the positions that where the boat could be at after having left the start point and traveling in all these different directions. So if you leave the start point at the start time, you could be along this white line, anywhere along this white line. And there's a skill involved in reading this line and reading the isochrones in general and inferring what the weather is doing, which can be quite useful. So you can see that this line isn't simply a straight circle. It has a kind of an odd shape. There's points where it's traveling further. So at this point, it's traveled further from the start point than it has at this point. And the reason for that, as we know, this boat performs very well downwind. You would guess that these winds are more favorable for it traveling faster. So it's useful to look at the patterns and learn how to read them. Now, there's some areas where a very small change in the position of the cursor results in a very large change in the path it uses to get there, the optimized path. So for example, in this area, I'm moving the cursor very slightly, and the path it chooses, the optimized path to get to these 2 points, is dramatically different. So that's an important point to note. You may have this system set up to only show you paths, and you can have it generate an optimized path for you. And you may not, if you don't look at the isochrones, you may not realize how sensitive the situation you're in is to a small change in location. And if the system you use doesn't show you isochrones in this manner, then the system you use may not be informing you of what's going on. There are times when isochrone weather routing solvers are, in general, not just LuckGrib, all solvers are very sensitive to small changes in location. And we'll look at that, why that is. So it's not clear. This is all open ocean. So it's interesting to think, why is the system doing this? Why is a very small change resulting in such a large change in the path? So I call these things zippers. It's where you approach some kind of feature and the isochrones are wrapping around it. We'll watch the isochrones advance towards this area, and then it's falling back and then going around, and then it meets up again behind whatever is happening here. So if you think about that a little bit, and we look at the weather, the group file, we can see what's happening is that in this weather system, we had the high pressure system north of Hawaii. And in the middle of a high, the winds become very light. We're actually seeing calm wind barbs. So the wind at these circles is less than 2.5 knots. So as you would guess, in very light winds, the boat can't travel, so it kind of stalls out. It's bobbing around here. Whereas if the boat was to travel north or south of that light wind area, it's able to go much quicker. And eventually the boat's able to wrap around that calm area and meet up again. So this is actually, it's a useful thing to look at. These zippers end up being very important areas to study. So I would encourage you quite strongly not simply to generate paths and follow them. As you generate paths, you should study these isochrones and determine how sensitive they are to changes in position. Because even though you may be traveling to this point, that's exactly where you want to travel to. Because of all the uncertainties involved with the weather forecast, this point is now 7 days into the forecast. And by the time you get to this point, the forecasts you'll be downloading at that time will be somewhere between subtly and dramatically different from the forecast we see at this point. So everything's an approximation, and you need to be careful with what the system is telling you to do. And I encourage you to think of it not as it telling you what to do. It's showing you, it's helping you understand what the weather systems are. So I'll go through one more example quickly of a zipper, kind of helping you understand what's going on, which is I'll make a new vessel. I'll copy this vessel, so I'll select it, copy the selected one. So there's a copy now, which is called copy of Bay. So I'll go down here, I'll use that one. And what I'll do is I'll back up, I don't know, here somewhere, have a system start at that point, at that time, and I'll have it go over here, target point, solve. So there's an obvious zipper behind the island, and clearly if you were to travel from that start point, going around the big island of Hawaii, if you want to end up over here somewhere, then clearly you either go north around or south around. So that's a very obvious physical meaning to what these zippers are. There's some kind of obstruction in the path, and you either go around it one way or the other. So that's a simple way to think about these things. In the example we saw earlier, it wasn't an island, it was a high pressure system. So they also become obstructions to the weather router. Do that again, solve. So this zipper, there's no island at this point, but because the winds are so calm, it's effectively working as a block to travel in that area. Okay, I think I've belabored that point enough. It's also useful at this point to look at, you may not have a destination in mind when you leave a port. Obviously, if you're racing, you do, but if you're cruising, you may decide to leave Nia Bay and head either to San Fran, say you want to get to Mexico quickly to get to the warm waters. You could stop in San Francisco, or you could stop in Los Angeles, or you could stop in San Diego, or somewhere in between. And in each of these three cases, if you look at the path north of San Fran, it's the same. So the path leaving Nia Bay, heading offshore, and heading down is the same path to go to San Fran, Los Angeles, or San Diego. At some point here, there's a big difference. So here, it's sensitive to this choice. So if you're heading to a port at this point, then it wants you to initially stay close to shore, jab out and jab back in again. But if you head just a little bit south of that, the optimum solution is to head further, quite a lot further offshore. So again, by studying these isochrones, you can find these sensitive regions and help make choices about how you navigate. As you learn to study isochrones, it's also useful to look at these close paths which can be generated. By default, the system will find the optimized path to any point in the solution space, and it will also generate these close paths. So the optimized path, the best path it chose, is the one that's highlighted with a white halo in this point, in this example. But you notice that there's all kinds of lighter blue lines, and those all show alternate routes which are within 5% of the best solution. So if for some reason you wanted to cover a competitor, or you had, if you're having lunch and you don't want to attack quite yet, if you're in this area, you can look at this and see that attacking exactly at that optimized turn may not be as critical. So let's give this a destination point to head towards. Where was that? I think it's in here somewhere. So make a target point, and now we'll resolve this thing. And there's the optimized path from Nia Bay, leaving at the time, the start point and start time, heading towards Hawaii. So you can go through this now in a variety of ways. Here's a picture which shows you the true wind speed at all of the different points and times for the whole route. So looking at this quickly, you can see that here's the patch of strong wind after the start. We avoided that a little bit by heading a bit more east. And then we have a light wind area, and we've managed to route between the very light winds to our north, and there's a light wind section to our southwest. We're going in the middle of those two. And then in this area, it didn't find a way of avoiding these light winds, so it chose to slow down. It was better to go into this area and slow down a little bit because the wind picks up again pretty quickly. And there's a wind veer at this point. And from here on, basically the winds are behind you. You're in the favorable vessel speed area for this boat. So LuckGrib makes these paths very quickly, and LuckGrib is fairly new. The first release with the weather routing system was last year, around April 2020. And there are systems on the market which have been around for a lot longer. A famous one is called Expedition, which is being used by racers all over the world. It's highly respected, highly regarded, developed by a person called Nick White. He's a bit of a famous racer, I believe. So I have an example of this route, which was calculated in Expedition. So if I'll turn those on quickly. Expedition has two ways of solving weather routing. Let's just have a look. Oh, it's the wrong target point. I'll move it over to where it should be. Yeah, there we go. And calculate it again. So now the target point for the LuckGrib route matches the Expedition routes. So looking at these, I'll turn off the color, go back to a simple display. So the black route is the grid solver in Expedition, and this red route, which I'll highlight, is the isochronal weather routing solution in Expedition. And it's difficult to see where the vessel is along this route. I can go through slowly and figure it out. I believe each of these time steps in Expedition is 1 hour. So you're able to find a point along the LuckGrib route and then advance by 1 hour exactly and compare the two. But generally what's happening is that the LuckGrib and the Expedition routes are a pretty good match. So initially LuckGrib is heading a little bit more, it's falling off the wind a little more than Expedition. And if you understand Expedition, you can understand why that is. I'm happy with the LuckGrib solution. And then LuckGrib is coming back in between Expedition isochronal solution and the grid solution. And it's a good match for the rest of the route. Here we go in between. There's the grid to the west and the isochronal to the east. Nice match. We're right in between those two. It's jibing around the same time, a little bit different. You never expect an exact match. There's a lot of decisions a software developer makes as they develop an isochronal weather routing solution, even down to how the system evaluates the weather forecast. So it may be that our systems they have slightly different answers for what the wind speed and direction is at all of these points. And all of these small calculations accumulate and they result in small differences. But here we go again. Expedition's heading straight downwind at this point, and LuckGrib doesn't do that. It prefers to only show you paths which you can sail. And in this example, I've told it to not exceed 35 degrees true upwind and not to exceed 170 degrees downwind true. So Expedition at this point is heading straight downwind pretty much, which is it's a different way of approaching the problem, which is interesting, but that's not the way LuckGrib works. So yeah, it looks good. I mean, towards the end, looking at the length of these journeys, it's a very close match, and the actual path through that quite complicated weather system is remarkably similar. Two more examples I have. There's also one in OpenCPN, which has also been around for quite a long time. And there's another product available called Qt VLM. So now we have 4 routes to compare with. And again, the Qt VLM is in purple. Let's see, the OpenCPN is over here in blue. So I'll highlight the blue one. So here's the 3 vessels. I have timing information for these 2 routes, the Qt VLM and OpenCPN. So you can see that there's 3 vessels moving along, and basically it's a good match. If there's interest, if you leave me a comment that you want to see this comparison in more detail, I can do that. But basically, I've gone through these examples in minute detail, and I'm happy with the way LuckGrib is performing. Where there's deviations, in all cases where there's a deviation, I prefer the LuckGrib solution. So yeah, it's been around for LuckGrib has been around for around a year. So the LuckGrib solutions are they're comparing very favorably to the other systems, and at the same time, the LuckGrib approach it offers you much more. It's a much richer environment to evaluate the paths that it's generating through the isochrones being generated and all the different ways of analyzing the results. And you need those. Just being given a path can be very misleading. If all you have is a path to follow, you don't know about all these sensitivities. And because everything is an approximation, what you need to have is an understanding of the weather, so when you sail in winds which are different than that were predicted, you'll have a good idea what to do. So yeah, that's a quick demonstration of LuckGrib. LuckGrib's weather routing. You can download the app for free. There's a free trial available for the app as well as the weather routing solver. So yeah, give it a try. Thanks for watching.